Hello, this is Mr. Collier, and today we're going to be finding the area of kites and a rhombus. So let's take a look at this kite here. First, let's talk a little bit about what a kite is. A kite has the following properties. It has adjacent congruent sides, so these two sides are congruent, and these two sides are congruent. So they have adjacent, that means next to, congruent, and they have equal measures, adjacent congruent sides. Okay, as a matter of fact, there's exactly two pairs of adjacent congruent sides in a kite. Also, notice that the diagonals of a kite, they are perpendicular to each other. So the diagonals are perpendicular. That's the symbol for perpendicular. They make a right angle. Okay, so that being said, we have a kite here, and we have to determine the area of a kite. So if you don't know the kite area formula, here's an easy way to figure it out. We have a kite here right now, and the kite actually fits very nicely into a rectangle. Pardon my rectangle, it's a bit squiggly, but we can draw a rectangle around this kite, and we notice that this distance is equal to AC, because it's the same size as AC here. And likewise, up here on the top, this distance of the rectangle is dB. Okay, so we've looked at this rectangle here around this kite. The area of that rectangle is going to be dB times AC. That's the area of the rectangle. But notice also in the rectangle we have this triangle. Let me use a different color. This triangle and this triangle are exactly the same. They're congruent, so the areas are the same. This triangle and this triangle exactly the same. This triangle exactly the same. And this triangle exactly the same. So basically the kite is half the area of the rectangle because of that. So in here the area of our kite is going to be area equals dB times AC out of 2, or half times that amount. So that's the formula for the area of this kite. We're going to take dB times AC, then we're going to divide by 2 because the kite is half the area of this rectangle that I've drawn. Okay, so let's go ahead and do that. We've got AC is, let's write down here, AC is 12, dB is 7, and then divide by 2. I could do 12 times 7 then divide by 2, or I could just do 12 divided by 2 right now, and I get 6 times 7, and that equals 42 is the area. Okay, so remember, when you're finding the area of a kite, you can multiply the diagonals and then divide by 2. Let's take a look at now some rhombi, which is the plural of rhombus. Okay, one rhombus, more than one rhombi. And here we've got two examples of some rhombi. In the first example, let's just take a look at a rhombus first of all. A rhombus, as definition, is 4 congruent sides. Okay, the definition is 4 congruent sides, but what happens is also a rhombus is also a parallelogram, because if you got 4 congruent sides in a quadrilateral, you're automatically going to have a parallelogram. The opposite sides are going to be parallel. So this is a parallelogram. But also notice that adjacent sides are also congruent because all 4 sides are congruent. So adjacent sides are congruent, so it's also a kite. So you can think of a rhombus in two ways. A rhombus is a kite, And a rhombus is a parallelogram. So you can use either of your area formulas to find the area of a rhombus, depending on what information you're given. In the first rhombus, we have the base and the height of a parallelogram of the rhombus. So this would be better to use the parallelogram formula. So we're going to use the area equals base times height formula for a parallelogram. And the following one, we don't know the height of this rhombus if you think of it as a parallelogram, but we do know the lengths of the diagonals here. So we're going to use the area of a kite formula for this one. So we can write the area of a kite as, we call it d1 times d2, diagonal 1 times diagonal 2 divided by 2. Okay, and then let's look at the first example. Area equals base times height, so that's 10 times 6, which equals 60. In this case, we've got centimeters, so the area is 60 square centimeters. And in the second example, we've got, now the diagonals are, this one's 3 and 3, so that's 6. This is 2 and 2, so this diagonal is 4. Divided by 2, which is 24 divided by 2, which equals 12. No units are given, so one thing you can do with that is just write units squared if no units are given. So that's the area of the second rhombus.